Enterprise integration firms like Accenture, Deloitte, IBM, EY, and TCS process millions of transactions a day. Getting hired there requires proving you can handle that massive scale. If you are interviewing for an SAP ABAP developer role, specifically for HANA, this masterclass is your roadmap. We are going to cover everything from basic table structures up through advanced wrap architectures. The most common mistake junior developers make is treating the interview like a vocabulary test. Reciting academic definitions will not get you an offer. Interviewers need to know if you can actually build scalable business systems. Technical recruiters are looking for candidates who can take a messy, real-world business requirement and translate it directly into an optimized technical implementation. To prove you can do that, you need to understand the exact trajectory of the interview. They will start with basic ABAP fundamentals to test your baseline logic and rapidly scale up to advanced HANA and wrap architectures. Your ultimate value as a developer is measured by your ability to integrate business logic. This is an evaluation of your applied engineering, not your memory. Technical interviews almost always begin with a review of your resume. Every project listed will be used as a launchpad for deep technical probing. From there, they will test your ABAP fundamentals. Your proficiency in loops, conditional statements, and modularization techniques is a non-negotiable baseline expectation. This brings us to a classic high-priority trap question. What are the types of internal tables? Do not just list off standard, sorted, and hash tables. Naming them out of context shows memorization, but fails to prove you can deploy them. The optimal way to answer is framing these tables within a practical scenario. Imagine processing an enterprise dataset of 1 million booking records. If you frequently search using a unique booking ID within a standard table, the system performs a linear, line-by-line scan. At scale, this creates a severe bottleneck. By utilizing a hash table instead, the unique key allows for instant, direct retrieval, maintaining optimal efficiency. You must also specify exactly when to use statements like read table, loop at, and binary searches within these real project contexts. Technical knowledge of search commands is ineffective if the table structure forces a linear scan on a million-row dataset. Interviewers then move into database operations. You need a rigorous understanding of joins, aggregate functions, and when to deploy OpenSQL versus native SQL. To show you are up to date, you should actively demonstrate your knowledge of modern SAP syntax. That means calling out inline data declarations and the use of the @ symbol for host variables. You should explain that OpenSQL is heavily utilized because it maintains strict database independence while simultaneously leveraging the underlying optimizations of SAP HANA. The discussion will likely shift to object-oriented ABAP, often prompting you to define concepts like encapsulation and polymorphism. Reject the urge to recite textbook definitions. Instead, connect these object-oriented principles directly to how you structure modern business logic. For instance, explain how organizing your business logic into highly specific methods is a strict requirement for executing behavior implementations, like in a travel booking application built with wrap. Object-oriented ABAP provides the structural foundation required to maintain and scale modern enterprise applications. Handling immense data velocity, taking raw, chaotic information and locking it down into an accessible structure is a primary differentiator for junior enterprise candidates. This brings us to the code pushdown architectural strategy. Understanding this concept is non-negotiable for any modern SAP interview. In a traditional SAP ECC architecture, the application layer has to pull and process massive raw datasets directly from the database layer, creating a severe bottleneck. The SAP HANA model reverses this. By utilizing in-memory computing, complex calculations happen inside the database itself. Only a thin, finalized data stream moves up to the application layer. This model relies on column-based storage, which executes rapid, aggregate analytical queries far more efficiently than legacy row-based storage. To execute this code pushdown, developers use Core Data Services, or CDS. Interviewers will ask you exactly why these have replaced classical database views. CDS views integrate business logic and metadata annotations directly at the database level. You must know the distinctions between interface, projection, and consumption views, and be able to articulate how associations provide smarter data linking than standard joins. Pushing calculations into the database with CDS is how a developer proves they can design for the HANA architecture. For candidates targeting SAP Cloud roles, the RESTful ABAP programming model, or RAP, is the absolute highest priority technical topic. When mapping out managed RAP, you start at the foundational layers. Data moves from the database table into the CDS view and then to the behavior definition. The architecture then expands through the middle layers. The behavior definition connects to the behavior implementation, which structures the logic, before exposing it through a service definition and a service binding. Finally, the backend logic connects to the user interface by linking that service binding to OData Services, terminating at Fiori Elements. Interviewers will frequently prompt you with a practical scenario, asking you to walk through your exact implementation of a travel booking application using this model. You need to explain how basic create, read, update, and delete operations are natively handled and optimized within this RAP framework. Detail how you use validations to enforce strict business rules, like rejecting an overbooked flight, while utilizing determinations to handle dynamic state changes in the background. Articulating this continuous flow proves that you can architect an end-to-end, cloud-ready enterprise application from the database up to the user interface. At this point, the interview shifts into the project discussion phase. Senior interviewers often spend significantly more time here than on theoretical trivia. You must take complete ownership of your project's architecture. Be prepared to confidently defend your database design, testing approach, and how you resolved critical challenges. The formula for a perfect project explanation is simple. You must explicitly tie the deployment of specific technologies to tangible, real-world results. Technical brilliance alone is entirely irrelevant if you cannot explicitly connect your code decisions to a solved business problem. The final stage of the interview will test your behavioral traits, with HR questions regarding your career motivations, personal strengths, and willingness to relocate. The optimal strategy here is consistency. Provide concise, rigorously honest answers that are entirely supported by specific, past project examples. During this final phase, your technical competence must perfectly lock together with clear, honest communication about your past experiences. Top-tier SAP interviews prioritize architectural logic over memorization. They evaluate your business value, not just your syntax. To prepare, follow a strict 4-step revision plan. First, secure your fundamentals in tables and SQL. Second, master object-oriented ABAP. Third, understand HANA and CDS. Finally, learn the RAP architecture. In your final days of preparation, ruthlessly review the actual code you have built. That code is the ultimate undeniable proof of your practical competence. Successfully completing the transition from a textbook student to an applied enterprise systems engineer is the singular path to securing a role at a top-tier integration firm.